I do recommend strongly you write the IP addresses down that you see on the screen right now. The IP address of our PC is 192.168.1.0. It has a subnet mask of 255.255.255.0 and a default gateway of 192.168.1.1. And let's go through our walkthrough, if you will, of the routing process. And we're going to see several different scenarios here. This is our walkthrough, and then of course later we'll be playing the game on live Cisco routers. But here we've got two possibilities when this host wants to send data as far as the destination IP address. It's either on the 192.168.1.0 network or it's not. No gray area there. Now, if the destination is on the same subnet as the host, the packet's destination IP address, when it leaves that host, the source host, will be that of the destination. And you might think, well, that makes perfect sense, but that's not always the case. But here, the PC at 192.168.1.100 is sending packets to the host at 192.168.1.15. It's a host on the same subnet. There's absolutely no need for the router to get involved. In effect, these packets really go straight to 192.168.1.15. Now, that's all fine and dandy, but what if they're not on the same subnet? Well, at this point, if 192.168.1.100 wants to send packets to the host at 10.1.1.5, the sending host knows darn well it's not on that same subnet. So in this case, the host will send the packets to that default gateway we mentioned earlier. And in this case, that's the router's Ethernet 0 interface. Remember, that's what we had configured as the default gateway, 192.168.1.1. Basically here, the host is just about passing the buck because he's saying, you know, I don't have the faintest idea where this address is, so I'm going to send it to my default gateway and let the default gateway figure it out. You know, I don't know what to do with the packets. Now, nothing wrong with that, but the packets destined for 10.1.1.5 are now coming into the default gateway. They're going to arrive on the router's Ethernet 0 interface at 192.168.1.1. So at this point, there are three possibilities regarding the destination. They're either destined for a network directly connected to the router. Or they could be destined for a non-directly connected network that the router has an entry for in its routing table. Or it could be destined for a non-directly connected network that the router does not have an entry for. And I want you to see all three of those scenarios. First off, with how a router handles a packet destined for a directly connected network. And here we're going to use something a little bit different here, different setup. And on the router, I put left right here because I hate it when people try to just squeeze E0 here and E1 here and squeeze in the addresses. It's a lot easier to read it this way. So just remember that the left interface that we're working with here is the Ethernet 0 interface, and the right one, of course, is Ethernet 1. Now, the router has two Ethernet interfaces. The switch ports are not going to have IP addresses that get involved in this, but the router Ethernet interfaces, of course, will. Now, host A at this point sends a packet destined for host B at 21.1.1. The router receives that packet on its Ethernet 0 interface as the default gateway and sees the destination IP address of 21.1.1. Just like this is exactly what's happening. Packets are coming in on Ethernet 0. Now the router is going to check its routing table and see if there is an entry for the 20.0.0.0 network. Now we are assuming, of course, no static routes or dynamic routing protocols have been configured. We're just looking at connected routes here. And the router's IP table is going to look something like this. Sorry, this one's split up over two screens. But you'll notice that this particular table, I should say, where it has two codes, in reality, we're going to see about 20 or 25 codes there. We'll see that on the live equipment. I just parsed that away because I wanted us to concentrate on these two particular codes. It can be a little intimidating when you see all those codes at one time for the first time. So I want to introduce it to you gradually. And you can see these two connected routes. That's what would be in the routing table. Now, you see the C and the S there next to the word codes we saw on the previous screen. Again, you will see a lot more codes there, but C and S will always be up there, and that's what we're concentrating on here. You also don't see the mask expressed here as 255.0.0.0. You see it as /8. This is prefix notation, and I mentioned this several different times during the course, so you may have seen it before or you may not have, but just a quick reminder, This is prefix notation, and the number behind that slash simply represents the number of ones at the beginning of the network mask when it's expressed in binary. And that 8 is pronounced /8. And boy, you're really going to love it when you're at meetings and you don't have to say, and then we're going to use a mask of 255, 255, 255, 240. You can just say slash whatever, and you're good to go. Now, here's the binary string for 255000. We know what that's going to look like. Anytime you see 255, the octet is going to be all ones. When you see a 0, it's going to be all zeros. So this one you'll be converting in your head with no problem at all, is a /8. Now, let's go back to our network here. And the C indicates a directly connected network. And there is an entry for 20000. We saw it. It's right there, the top one. So in this case, the router's got an entry for those packets, and it just simply forwards them out E1 with the destination IP address of 2111. Simple enough, right? Nothing to this routing stuff. And the thing is, your tables, of course, through your studies are going to get more and more complex, because you'll have tables at one point in a production network or in a lab where you have connected routes, static routes, and dynamically discovered routes when you're running routing protocols. But the logic still comes down to this. It's going to look up that route in the table that it needs, look for the best match, look for the most efficient route, and then send the packets on their way. And if there is no match and we don't have a default gateway configured on the router, then we're out of luck. The packets aren't going to get where they need to go. Now, let's talk about how the router handles a packet destined for a remote network that is present or not in the routing table. Pretty long-winded there, but a good example for you here. And we've added some devices here to our network, so let's quickly revisit our IP addresses here and give you a quick troubleshooting tip as well. Host A is going to try to send packets to host B, and notice that we've introduced another network and another router. So Ethernet 0 on this particular router, this is going to be router 1, and that's Ethernet 0, 10.1.1.2, left interface, Ethernet 0, the right interface, Ethernet 1, 21.1.1. Ethernet 0 on this router, router 2, is going to be 21.1.2 on this left interface and 31.1.1 on the right interface. Now, when we start this one off, if host A wants to send packets to host B, we do run into a problem even if host A has 10.1.1.2 configured as its default gateway, because router 1 is going to get that entry or get those packets, and they're destined for 30.0.0.0/8. Well, that router is going to look in its table and say, I don't have any idea what you want me to do with it. Because, again, there are no static routes or dynamic routing protocols in action on a Cisco router by default. Once we apply these IP addresses and open the interfaces, we'll see some connected routes, but that's about it. Or that is it, actually. So here is the routing table for router 1 at that point. It receives the packet for 31.1.2, does a lookup, and says, what do you want for my life? I have no idea what to do with these. And with no route to 30.0.0.0 and no default gateway set on the router, the packet would simply be dropped. That's exactly what's going to happen. And obviously that's not the kind of thing we want to have happen. So here's your result. Packets for 31.1.2, they're going to come in on the 10.1.1.2 interface. They're not going to be stopped at the interface level. But when those packets come in and hit what we call the routing engine looks it up and says, I don't know what to do with this, and they're just dropped. Now, we have two solutions to this, both of which we're going to work with throughout the course. When we get to static routing, I've got quite a static routing live lab for you. But again, I want to walk through one of these as well. Let's try a static route right now, and I want to introduce you to that syntax as well. They are created with the IP route command. And you can see that I simply on router 1 put IP route, and you put the network followed by the mask, followed by either, and those of you who have taken my classes before are already grinning and saying, oh, here he goes. But it's so important to remember you have two options here at the end of the IP route command. Again, you'll see this live several times, but the key is it's either going to be the local router exit interface, the interface that you're basically throwing the packets out of, or you put in the IP address of the next hop router. You never put the IP address of the local router. The router actually won't let you do that. So then what we end up with is a routing table that has a route for the 30.0.0/8 network. And there it is. And you can see the letter S indicating that. And that means that any packets for that particular network, this router 1, is just going to take them and send them right out Ethernet 1. And see, then they'll get to this router 2, which does have a connected route to 30.0.0/8, and then the packets will get where they're supposed to go. So the static route helps us get those packets. Router 2 has no problem with routing packets to 30.112 because router 2 is directly connected to that network. And here's our success. This is exactly what happens. Packets come in for 30.112. Now that this router 1, has a static route, Ethernet 1, it's saying just any packets for the 30.0.0 network, just shoot them out Ethernet 1, shove them out there, however you want to put it. Just send them right out Ethernet 1, and we'll just hope the next hop router downstream can take care of them. And as a matter of fact, in this network, that next hop router can, because it's directly connected to that particular network. Now, something to watch here, and I want to introduce this to you. It's a very important troubleshooting tip. Just because A can reach B doesn't mean that B can reach A. And I see this as host C will respond to host A. I'll change that and make it host B. But if host B wants to respond to host A's packet, there's going to be a problem at router 2. And why? Because the incoming packet coming back from B, if we're going from B to A, the destination IP address is going to be 10.1.1.1. Well, this time, when this router 2, gets that packet, it would look in its own routing table and say, I don't have any idea where the 10.1.1.1 network is or the 10.0.0 network is. Again, we'd have to create or write another static route on this router pointing the other way, or we would have to get a dynamic routing protocol up and running on both of these routers so they could exchange routes. And that is probably the way you would go in a lab and a production network. But in our static routing section, we're going to build connectivity just using static routes. And you'll see how fun and non-scalable that can get. But I'm definitely not mocking static routing. I wouldn't want to run an enterprise network on it. But it's a great tourniquet, if you will. Because if you are having some massive network problem, something just goes terribly wrong in your network, and people can't send packets outside of the organization for whatever reason, sometimes applying the right static route and knowing how to do that and just saying, okay, send all these packets to this router outside the network while I fix the problem. And what that does is it gets everybody up and running while you fix the problem. And that does make things a lot easier when there's no one leaning over your shoulder and no one's screaming bloody murder at you over the phone or anything like that. So again, static routes can really come in handy as a troubleshooting tool to get people up and running while you do the real troubleshooting. So let's go forward here to that discussion. This is going back to what we talked about earlier, because this is why we want to keep hosts in one subnet on one side of the router. And this is the one we looked at earlier, the following topology, how we don't want to configure the network. And now that we've gone through some fundamental routing process examples, you can see why this is a bad setup. Because let's say that a packet destined for 192.168.117 is coming in on another router interface. Could be another Ethernet interface, could be a serial interface, doesn't matter. Packet comes in for 192.168.117. The router receives that packet, and it's going to do a routing table lookup for 192.168.10/24. It sees that network is directly connected via Ethernet 0. So what's it going to do? It's going to send those packets out Ethernet 0, even though that's not where this particular host is, because it's over here. So you can see that the packet for 1.17 with this situation would be sent out the wrong interface, and then you've just got a real mess. Now, in future studies, you're going to see there are ways we could get the packets over to 1.17. It's not a hopeless case, but it just makes life so much easier. And if we keep all of our members of a given subnet on one side of the router, so to speak, it does make life a lot easier. It makes life easier in your labs, and it makes life easier in your production networks as well, and we really like that. This concludes our look at routing fundamentals. Like I said, in the future, in other parts of this course, we're going to be doing some static routing live labs. working with OSPF and some other routing scenarios I've come up with. So just make sure you're comfortable with the fundamental router operations that you've seen here, as I'm sure you are, and then just head to the next section. I'll see you there.